Chapter 5 Summary and Review Part 1. Let's get started. Open your book, get some paper and a pencil and your protractor, and we are going to tackle this together. We're going to start with the words on the left, the basic terms, the theorems that we've learned this year in this chapter. So the first one is the addition property. If A is greater than B, then A plus C and B plus C, the A plus C will be greater than it still because we're adding the same thing to both sides. If you imagine these animals on a scale, the elephant is greater than the bat, of course, but if we add a monkey to both on the scale, the elephant plus the monkey would still be greater than a bat plus the monkey. So this is an addition property. Then we have the subtraction property, which is the same thing except the opposite. If we have A is greater than B, then A minus C is greater than B minus C. So if we have the same amount subtracted from both sides, it will still maintain the same inequality. The multiplication property is the same as well. So A is greater than B and C is greater than 0. So A times C is greater than B times C. The division property. If A is greater than B and C is greater than 0, because you cannot divide by 0, then A divided by C is greater than B divided by C. And you can visualize this pretty well with money. If you had $20 and it's greater than 10, if you divide both by 2, you will still have the same inequality of 10 being greater than 5. The transitive property. This one is coming up often in our review, so make sure you pay attention. If A is bigger than B and B is bigger than C, or greater than, then A is also greater than C. So this one is telling you two things first, and then you come to the conclusion of the third. And if you notice, what they start with is A is greater than B, and B is greater than C. And then they use that last term C in the conclusion of the inequality theorem. We start with A and with C. You can imagine this. If an elephant is greater than a monkey, that's A is greater than B, and B is greater than C, a monkey is greater than a bat. Therefore, an elephant would be greater than a bat in size. The three possibilities property. This also will come up in your review. So either A is greater than B, A is equal to B, or A is less than B. There can only be three possibilities. These all cannot be true at the same time, and neither can two be true at the same time. The addition theorem of inequalities. And so let's look at this one. This one's just like our addition one. If A is greater than B and C is greater than D, then A plus C is greater than B plus D. And pay close attention. We have our starting terms A and C. Over here, we're adding A plus C. So we're already adding the two larger terms that were already told to us that were greater than the second term. And then we have B and D over here on the right side. So they are being added together. And so therefore, the two greater terms are still added together and are going to be greater than the two lesser terms. You can use dice to imagine this. So if A is our 6 and B is our 5, A is greater than B. Then if we have C is 4 and D is 3, we have A is greater than D. 4 is greater than 3. So then if you use those same dice, the A and the C, which is the 6 and the 4, and then the B and the D, which was 5 and 3, that would be 10 is greater than 8, and that is true. Whole is greater than part theorem is just a whole pizza's greater than a piece of pizza, correct? And so no matter how many pieces you have, pieces will always be smaller than the whole. That is what this is saying. The exterior angle is something that we learned this year. And the exterior angle is if we extend this side of the triangle and we create two angles that are a linear pair. This is the interior angle and this is the exterior angle. It is outside of the triangle. And we also have these interior angles. These interior angles, since they are opposite of the exterior angle, they have a special name called the remote interior angles. And we have a special rule about these, that if you add the exterior angle, the two remote interior angles, it will always equal your exterior angle. So let's remember how that works.
So let's practice finding the exterior angle. So this x is our exterior angle, and it will equal the sum of our two remote interior angles. So we have the angle 1 plus angle 2 will equal our exterior angle. So over here, we have another triangle. We have an exterior angle that we do know, which is 130. And then we know one of the remote interior angles was 60, and we do not know this one. So to find this, we're just going to say x plus 60 equals 130. And then we subtract 60 from both sides. X equals 70 degrees. And we can label that here 70 degrees. And we know all interior angles of a triangle add to 180. So we know that we have 180 degrees, and we already know 60 plus 70, which is 130. And so this angle that's left is 50 degrees. Another way you could have known that is we have two supplementary angles right here. They are a linear pair, and we have 30 degrees plus 50 degrees equals 180 degrees.
Okay, so to see that one more time, the exterior angle is the sum of the two remote interior angles. Theorem 15, the sum of any two sides of a triangle is greater than the third side. So no matter what sides we add, two sides will always be greater than the third side. Also, we had Theorem 13, if two sides of a triangle are unequal, the angles opposite them are unequal in the same order. And also, this is saying the same thing but opposite. If the two angles of a triangle are unequal, the sides opposite them are unequal in the same order. So these are the converse of each other. And so they're telling you that the sides of a triangle will be in proportion to their angles. So the longest side of a triangle will be across from the largest angle in the triangle. And then your second largest angle will be across from your second largest side, and so on. So here's an example of a right triangle. So our right triangle, our largest angle is 90 degrees, and the measurement of this length of side is 5. And then our next largest angle is 53.15 degrees, and it is across from our second to largest side. And 36.87 is across from our smallest side, and it's our smallest angle. Here's another example, and this one is an isosceles triangle, because I know this because this is 4 length, this is the 4 length, and this is 6. So we have two sides that are the same length, and across from this is 38 degrees, and across from this side is 38 degrees. And so their angles are also equal. The largest angle is 104 degrees, and that is also across from the longest side. And this pattern continues. Here's another isosceles, and here's an equilateral triangle. Here you can see that all angles are equal, and therefore all sides are equal. Okay, here's a problem from our book exactly that we want to look at. So in the figures below, point M is the midpoint of LR. You see L left, that's what it stands for in this word problem, and R right. The goal is behind them, and this is the midpoint. K and S represent the positions of the keeper and the shooter. In this figure, this shooter is centered so that SL and SR are equal. So these lines are equal. Draw the figure and mark it as needed to give a reason for each of the following statements. So number 15 says, draw it. You should draw it on your paper the best that you can and mark it so that we know that what is equal and what is not. So since this is the midpoint, we know that LM and MR are equal. It also told us, it's given, that LS and RS are equal. And therefore, since we have side and these are angles that are the same, we know that this side is equal because it's literally right next to each other also. 16 says, give a reason for the following statements. So L, M, and MR are equal. How do we know this? Well, because it is the midpoint. The midpoint of a line segment divides it into two equal segments. 17, SM equals SM. When you have the same thing on both sides, remember that's like a reflection, and that is the reflexive property or theorem. Okay, number 18, look at the whole triangle. Triangle SML is congruent to SMR. Okay, how do we know these are exactly congruent? Well, we've marked the sides, correct? And we know that 3 and 4 are the same angle because they have divided a line in half exactly. Therefore, we know it is the same also because of side, side, side. 19, angle 1 is equal to angle 2 and angle 3 is equal to angle 4. How do we know that these are equal? Well, the corresponding parts of congruent triangles are equal. Because these triangles are congruent, their parts are congruent as they correspond as well. And number 20, SM is perpendicular to LR. SM is perpendicular to LR. How do we know this? If the angles in a linear pair, right here, 3 and 4, are equal, their sides must be perpendicular. So it's not like 80 and 100. These are equal. So therefore, these must be right angles. Another question, another set of questions in our textbook I wanted to go over, especially in the figure below, the shooter is closer to the left side of the goal now. So we have the left side of the goal, the right side of the goal, M, the midpoint. We have our keeper and then the S shooter. And it tells us that SL, right here, is less than SR. Now, it already looks like that, but let's think of reasons why. Number 21, it says draw the figure and mark it. So you should draw it and you should mark it. And you should mark it as such. We know that 1 dash here and 2 dashes here because this is longer and this is shorter. Okay, next, give a reason for the following. Angle L is greater than angle R. Angle L is greater than angle R. Well, we can definitely tell that with our eyes, but how could we tell that knowing? Well, what are the things that we've learned this chapter? That's what you should think of. What theorems have I learned that would match a reason for this? Well, what have we just marked? We've just marked the length of sides. What have we learned just a second ago? That basically the angles across from the lengths of sides will be corresponding to their degrees. So because SR is a longer length, the angle across from it should be larger than SL. Because this is a shorter side, it will have a smaller degree of angle. And the way you say this is if two sides of a triangle are unequal. Are they unequal? Yes, we have a larger and a smaller. Then the angles opposite of them are unequal also in the same order. Number 23, angle 4 is greater than angle L. So let's see, angle 4 and angle L. Now we already can tell that it is more obtuse, but what is the reason why? That's what they want to know. How do we know this? Let's look and see the transitive property. And now, and how is it transitive? Let's look. So angle 4 is greater than angle L. We just talked about that in 23 and the reasons why. So transitive, what are we knowing? If that, then this. So if it is larger than L, it's also larger than angle R. Does that make sense? Okay, and so let's look at the last one, number 25. SR is greater than SM. SR is greater than SM. These two line segments. How do we know this is true? Well, if two triangles or two angles of a triangle are unequal, the sides opposite them are unequal in the same order. So number 22 was emphasizing the sides. We knew from the sides that the triangles were unequal. Now we know by the angles. So let's look at those angles one more time. SR, what's across from SR? L. And what is across from SM? L. The same angle. Okay, guys, if you have any questions, let's talk about it in class or send me an email, but I think you are getting really prepared for your test. Great job. Bye.